Something like this could totally show up on your test. All right, so we know W is parallel to X. I'm going to go ahead and add the markings so that we're reminded that it's parallel. But the ones D and E, they're obviously not parallel. It doesn't even look like they are. Congruent, supplementary, or neither. Angle 1 and angle 3. Now, those are corresponding angles, right? But corresponding angles, the theorem says they're only congruent if two lines are parallel. Which lines need to be parallel for 1 to be congruent to 3? D has to be parallel to E for 1 to be congruent to 3. And they're not parallel, so neither. Next one, 1 is congruent to 6. Oh, 1 and 6, sorry. They're not congruent. 1 and 6, those are same side interior angles. Same side interior angles are supplementary if the lines are parallel. Are the lines creating 1 and 6 parallel? They absolutely are. So 1 is supplementary to 6. 1 and 5, alternate interior angles. Alternate exterior angles are congruent if our lines are parallel, and W is parallel to X, so 1 is congruent to 5 for sure. Confirmation. 6 and 5. Congruent, supplementary, or neither. Well, 6 and 5 are a linear pair. They don't rely on parallel lines at all. So we don't care if the lines are parallel. A linear pair is supplementary all the time, no matter what. All right? Homework answers. Check your homework answers. Perpendicular bisector was the name of your homework. How was it? Pretty easy? Let's look at this section in the middle here, 5 through 7. Use the information to conclude if C is on the perpendicular bisector of AB. Explain your reasoning. All right, so if C lies on the perpendicular bisector, then C, we learned from the perpendicular bisector theorem that C would be equidistant. C would be equidistant from A and B. It would be the same distance from A and from B. So look at number 5. Is C equidistant from A and B? No. C's 8 away from A and it's 7 away from B. What is this picture missing? What's missing? So the answer is no. What's missing? It's not a perpendicular bisector because it's not perpendicular. It's a bisector for sure, but it's not perpendicular. It's missing the right angle symbol right there. Okay, next one, number 6. Number 6 is just ludicrous. Come on. That is not the perpendicular bisector, right? To be the perpendicular bisector, it would look more like that, and it would need a right angle. Okay? C would have to lie on this over here. So that one's no. Perpendicular bisector needs to intersect at 90 degrees. You love that word? Okay. Number 7. Why is this one not? We've got the 90-degree angle. We have the tick marks. But the tick marks are in the wrong spot, right? Is CP a perpendicular bisector? Well, it's perpendicular, but how do I know how long AP is? I don't know if AP is congruent to PB. I don't know. Yeah. So that's why there's 3 no's in a row there. No, no, no. Okay? 10A. All of those segments, SV, TV, and UV, are perpendicular bisectors. So they are equidistant from the endpoints of the segments. Okay? So, if I look at point V, and V is 26 away from P, then how far is V away from R? Well, if V lies on the perpendicular bisector, if it's 26 away from P, then it better be 26 away from R. So you're using the perpendicular bisector theorem to find the missing links. VQ is also 26. If V is 26 away from R, then V is 26 away from Q because of the perpendicular bisector theorem. Number 14 says to use point slope to find the equation of the perpendicular bisector of AC. So first we need to know the slopes, right? So did you already get that part, the slope of AC? So we already knew the slope of AC was 4/3. So the slope of a line perpendicular to AC would be -3/4. Now to use point slope form, we need a point and we need a slope. What do you think that point is going to be? We have a slope. What's the point? Good. If it's a perpendicular bisector, it must go through the midpoint. It has no choice. So to find the midpoint, the cheating way, well, it's not really cheating, but the using the graph way, instead of rising 8 and running 6, just rise 4 and run 3. Just go half and half. So I'm going to rise 1, 2, 3, 4, and run 1, 2, 3. So I avoided the midpoint formula because I had a picture. When you have a picture, you can avoid it. All right, so what is that coordinate? It's 4, 6. 4, 6. So I have a point and I have a slope. Here we go. This will help you for your quiz today. Y minus Y equals M X minus X. So that is point slope form. You don't have to memorize it. You get a formula chart. All right, let's distribute. Y minus 6 equals -3/4 X plus 3. How in the world did I get plus 3? Well, the negatives cancel. Negative times negative is a positive. And the 4's cancel. That 4 is in the denominator, and the other 4 is in the numerator. So they cancel, and all you're left with is 3. Add 6 to both sides. And there's how you get Y equals -3/4 X plus 9. Okay, write the equation of the given line. Very good. Y equals 2. So which axis is this hitting? It's hitting the y-axis. It's going to be a y equals, and we notice that it hits it at 2. What is the slope of this line? Of course it's coffee. What's the slope of this line? 0. The slope of the line is 0. The equation of the line is y equals 2. Write the equation of the line with undefined slope that passes through -3, -5. Don't say it yet, please. Perfect answer. Yes. The answer is x equals -3. We know if it has undefined slope, it's going to be an x equals problem because it's going to hit the x-axis. It's going to be a vertical line that hits the x-axis. Well, where is it going to hit the x-axis? You just grab the x-coordinate. The x-coordinate happens to be -3. Vertical line, undefined slope. Good. Next problem. What is the slope of a line perpendicular to x plus 7y equals 3? While we're waiting on him to answer, we can start solving it. You do not know the slope of this line unless you use the little trick I taught you, but you don't know the slope until you get this into slope-intercept form. So first we would move the x over. 7y equals -x plus 3. Then we would divide everything by 7. This would cancel. Y equals -1/7 x plus who cares? Because we don't care about the y-intercept. And good. So if we want to be perpendicular to -1/7, the opposite reciprocal is 7m. The slope equals 7. Good job. This one's easy. Let's do this one right away. Anas, this one's yours. What do you get? Very good. The answer is 1. Because, of course, when you move the x over, you get y equals -x plus 5. And the opposite reciprocal of -1 is 1. Final answer. Now we're doing some parallel ones. What is the slope parallel to 3x plus y equals 7? Megan, this one's yours. Oh, you were quick. Very good. If we want to be parallel, just make sure you're changing nothing at all about the slope. You are changing nothing. Students always want to take the negative off or something. Parallel lines have equal slopes, so the answer was -3. Awesome. Parallel, perpendicular, or neither? Start solving these. All right, so you don't know the slope until it's in slope-intercept form. Negative 3y equals negative 6x plus 7. Divide everything by negative 3. All we care about is the slope. The slope of this one is 2. Come over here, do the same thing. Negative y equals negative 3x plus 11. Divide everything by negative 1. Y equals 3x minus 11. Neither. Very good. Slope of 2 and a slope of 3. Neither parallel, perpendicular. All right. Okay, the other half of what the test is over is parallel lines and transversals. So we've got writing equations of lines, and we've got parallel lines and transversals. So don't forget which ones you set equal and which ones you add to equal 180. Don't forget what this looks like. Let me give you a visual. Okay, remember? So if you're given two angles that fall under that first column, you're setting them equal. If you're given two angles that fall under the second column, you're adding them to equal 180. Find the value of z so that m is parallel to n. Find the value of z so that m is parallel to n. So we would start this one by using vertical angles. 8x minus 81 equals 5x. We would move things over so that 3x equals 81. We would divide by 3. X is 27. Now, if I plugged 27 in, 8 times 27 minus 81, we get 135. Now, if that angle is 135 and we need m to be parallel to n, what would we get for z? We would need to get the supplement of 135 because they are same side interior angles, and that starts with an S. So our answer would be 45. Good. Okay. How do we do the next one? Ooh, find x so that A, you can use a highlighter on the test. You can use a marker. Find x so that A is parallel to B. Do you see some angle relationships we could use? I see same side, interior angles. Do you see them? We're going to use this transversal. What we're not going to use is that 125. It is no good to us. It was there to trick you. It's the number you don't use. What are we going to do with 57 and 3x minus 9? They are same side interior angles, so we're going to add them to equal 180. If it said make C parallel to D, then we would use the 125, but it didn't. Okay, this one's easy. Once again, adding to equal 180. They're same side exterior angles. We don't need to go through this. Ooh. Solve for x. And I know it's time to take your quiz. Now remember, every time you see arcs, that is like handed to you on a silver platter what the other angle equals. The arcs mean that they are identical angles. So that angle is 41. The other one with an arc is 41. Mark it right away. Now, how? Oh, here we go. This angle is corresponding with this angle, right? Corresponding angles. Corresponding angles are congruent. So you would just say 4x plus 1 equals 41 and call it a day. Okay? Good. X is 10, yes. Okay, last thing, promise. We need to remember what converse and inverse are because these could show up on the test. Hint, hint, wink, wink. Okay, so converse. Converse is when you reverse the hypothesis and the conclusion. They trade places. If two lines are parallel, then they have the same slope. If two lines have the same slope, then they are parallel. That's converse. Inverse is you're not. If two lines are not parallel, then they do not have the same slope. So for the test tomorrow, please know the difference between converse and inverse.